Hello students. Now if you see the entire metallurgical process, we have already done with ores and concentration. So now it is time for us to talk about the extraction. Now what is extraction, or how do we define the word extraction? Extraction is a process which is used to obtain metals in the free state from the concentrated ore is called as extraction. Now what do you mean by the word free state? It means metal in the uncombined state or metals in the elemental state is called as free state. As we already know, in concentration we had metals in the form of a compound, and in concentration we were just trying to remove the earthy impurities. So metal oxide is now free from the gangue. Metal sulfate is now free from the gangue. So what are we doing on the name of extraction is, from a metal oxide we are removing oxygen and getting a free metal. From a metal sulfate we are removing the sulfate group and getting a free metal. So this is exactly what is the word free state or uncombined or elemental state means. Now since we know what is extraction, now let us talk about the steps involved in the extraction. Extraction involves 2 steps. I repeat, extraction involves 2 steps, whereas concentration had 4 methods. Methods, we have a choice. Steps, we need to follow. Yes, and when I say extraction involves 2 steps, now inside those 2 steps there are several methods which might be possible. So what is the first step, sir? In the first step we have a metal compound, and this metal compound is a concentrated metal compound which is free of earthy impurities. So first we need to convert this metal compound into a metal oxide. That is our first step. And in the second step we can convert this metal oxide into a free metal. Converting a metal oxide into a free metal, which is obviously indicating it is the removal of oxygen, and removal of oxygen is also called as reduction. Whereas if you see the first step, converting a metal compound into a metal oxide, that means we need to add oxygen. So most of the time the first step can also be called as oxidation. So talking about the first step, that is converting a metal compound into a metal oxide, can be done by 2 methods. The first one is you can heat the metal compound in the limited supply of air, or you can heat them in the excess of air. Whenever you heat them in a limited supply of air, the process is called as calcination, whereas in the excess of air the process is called as roasting, and that is our first step. Now talking about the second step, which is reduction, can further be done by 2 methods. The first we can do with a chemical reduction, or we can use electricity, that is electrolytic reduction. Whenever you do chemical reduction and that chemical reduction is occurring in the aqueous solution, we call it as hydrometallurgy. But the same chemical reduction in the presence of heat is called as pyrometallurgy, and electrolytic reduction is also called as electrometallurgy. Now what we need to do is, we are just going to focus on the first step, and in the first step, converting a metal compound into a metal oxide is also called as calcination if we do it in the limited supply of air. So the next thing is, how do we define the word calcination? Now calcination is a process of converting an ore into its oxide by heating strongly below its melting point, either in the absence or in the limited supply of air. And that is the definition of the calcination. Now whenever you do calcination, the following changes will occur. The very first thing is the moisture content will be removed, and the second thing will be water is removed even from the hydrated ores. For example, if we talk about bauxite, which contains 2 molecules of water of crystallization, if you heat it, gets converted into alumina. So this exactly occurs when you do calcination. One more example goes this way. This is the hydrated hematite, after heating gets converted into ferric oxide, which is also called as hematite, which is free of water. Now I want you to remember, calcination starts with alphabet C. So this calcination can be used only for carbonates ore, or in general those ore which can be converted into its oxide purely by decomposition. So if you take an example of calcium carbonate, decomposes to give you the corresponding calcium oxide. This is exactly occurs in calcination. The second example is zinc carbonate gets converted into zinc oxide. Zinc carbonate is also called as calamine, getting converted into zinc oxide. And the third example is containing 2 carbonates, that is CaCO3 and MgCO3, gets converted into corresponding oxide, and this compound is called as dolomite. So what's exactly happening is, there is an ore and the carbon dioxide gas is coming out from the ore. So because of that, the ore can become porous. Now these are the following changes that can occur in calcination. Now since we know what is calcination, now the next question is, where is this calcination done? Now this so-called calcination is basically done in a furnace called as reverberatory furnace. The components of the reverberatory furnace are these. First of all, we have a charge hopper through which we can introduce the carbonate ores, and then there are air vents which can maintain the limited or the absence of air, and then there is a charge lining which is made up of the refractory material which can withstand a very high temperature. So first of all, what we do is we will introduce the charge. We will introduce the carbonate ores from the hopper. The ore particles will come and get settled down in the vessel, and because of the heating part of the furnace, the ore can get decomposed and the unwanted carbon dioxide gas can be removed from the other end. Now this is exactly how the reverberatory furnace works, and this is our first step, calcination. Now the kind of question that can be asked over here is this: heating of ore in the absence of air to remove the impurities is called as, and obviously the right option is calcination.